Hello and welcome to my assignment 3 presentation. I'm going to start with the light perceptron. So this perceptron aims to do what you see here on the left, which is um, try and classify pixels into try and classify the entire image as light or dark based on the pixel input. And this first example that you're going to see is specifically set up in a way that shows that we are in fact getting the correct weights. So if you look here on your left, the first set of weights are these, right? Negative 0.5 for the bias, 0.7, negative 0.2, 0.1, 0.9. So I hard coded those just to show you that, hey, we are getting, in fact, the correct thing. So I'm going to clear this out and run it. And just set a breakpoint somewhere here. So that is our first input set, -1, 1, -1, and the output should be 1, according to this, right? So we have dark, light, light, dark, which is what we have right there. And yeah, let's see what we get. So the first output that we get, it says it's -1, which is incorrect, and then it automatically learns and sets the new weights and goes to the next input in the sample, which is up here. So as you can see, the old weights were these 0.5, 0. Negative 0.5, 0.7, all that, and the new weights are negative 0.3, 0.5, 0, 0.3, and 0.7. Let's see if that is correct. Yes, so as you can see, we have negative 0.3, 0.5, 0, 0.3, 0.7. So yeah, that's just to show you that we are in fact getting the correct weights after completing the learn operation. But if we continue, then it continues with the rest of the sample, continues to learn. Once it starts getting it correct, it doesn't learn, and so on and so forth until we finish the entire set, and then it will show the final weights, which are 0.5, 0.5, 0.4, 0.3, and 0.7. So that's just the hard-coded example. Now I will show you just the regular example. So without the hard code, meaning we're going to just start at random when we populate, and that would be this file. So here the weights are being set to a random weight between 0 and 1, so 0.1, 0.2, all the way up to 0.9 are the initial weights, and the sample is that. So it's not set to start from dark, light, light, dark. It's just set to whatever this is. And yeah, so now I go ahead and run, set another breakpoint, clear this out. So that's our new input set. Weights are again random, although I really should round these values up, but it doesn't matter. It's not that big of a deal. So on the entire thing being light, it chooses light, which is correct. Okay, no need to learn there. Then it classifies that as light, again, is correct. Then it classifies this set as dark, but it's either dark or light with this input set right here. And then it learns, like, okay, then it sets the new weights. The new weights are being passed in, and it'll be the next epoch's current weight, and so on and so forth until it continues to learn. And let's see what the final weights will be roughly the same as the previous run, uh, the hard-coded one, meaning those hard-coded weights, but except this time the initial weights were random. So pretty cool. Um, I decided to take it to the next level after that and go to this, which is now I changed the perceptron to, instead of having a sample of just 4 pixels, now we have a sample of a picture pixels. So the 2 pictures we're going to be testing are this one, dark and light. And the way I classified, or the way I process these pixels, is because I'm only getting RGB values, no alpha. Because when you get the alphas for these pictures are always going to be 255, so they're kind of useless. I was expecting some pixels to have lighter or darker alpha, but that's not really how that works. It's just based on RGB. So I just take the RGB and get its mean and then use that as my thing. So let's go ahead and run that. This is complete optional for me to do. I just thought it'd be fun to actually use a real picture and try and classify it. So there you see it collects all the pixels in tuples of 3, red, green, blue, and then I enter my bias, which is 0.5. And for this run, we're doing the light image. So let's see if it gets the light image correct. The threshold, this is the interesting part though, that you have to set the threshold to 86, because if you take any one of those RGB values and you look at it on an RGB scale, the minimum that one of those colors has to be classified as light is around 85. 85 is the midpoint. So if you go 86, that's light. If you go 84, that's dark. So if you only had one value, and that value, because you don't need all 3 values to be considered light or dark. Like you can just have a lot of blue and then that blue would be light, or you can have less blue and that blue would be dark. So you don't need all 3, but if you do have all 3, then you just divide them all by 3. And yeah, so I went based off of that. So I set the threshold to 86, not 127, which is half of 255, which is the max that they can go to. No, you set it to 86 because there's 3 of them. So if we hit 86, the expected output for the light image would be 1, meaning bright. And yeah, so it gets 1. The weights, let me check the weights that I set them to initially. Right, so for this case, I hard coded the weights to 1. That's why I was able to guess it correctly. So if I were to train this thing based off a random set, the best weights that it can have is 1 for each pixel, because each pixel carries a lot of weight. It's not like, and I guess you would probably think like, oh, this is useless. Why not just calculate it on your own? Well, this perceptron would come in handy if, let's say, you only wanted to calculate if the perceptron, if the image was light or dark, but it had subtitles and you wanted to ignore the subtitles, then you would set the random weights and let it train itself that, hey, these pixels from, let's say, 3 rows above and the bottom 3 rows, let's ignore them. So that's where it would come in handy. But just to show again, like I did with the previous example, I kind of hard coded to show you that it works, and then I'll put the weights to random and then we'll see what we get. So now let me do the dark image. Which is this, right? So if I set it to dark with 1 as your weight, it collects all the pixels, 0.5, threshold again 86, expected output is -1, we get -1. So, and the way that this is determined is I just followed the PowerPoint and followed the instructions, which is like multiplying and adding and doing all that stuff based on the number of inputs. And yeah, basically that value is something to do with the 86. It multiplies by the threshold and determines if it's less than or greater than, by judging by the number of pixels. So yeah, pretty cool. Yeah, so it basically judges that as dark. So if we now go here and we set this to random, it'll probably get it wrong, but let's see. Threshold again, 86. Expected output, -1. Okay, looks like it got it right. But you can see now that there's a different value than what was previously there because the weights are affecting the output. So if I try light, again, it's completely random. So I guess the set that I got in that instance just happened to be good. So let's try that again. 0.5, threshold 86, -1. Again, a different output. So that shows you that we're getting different weights. So yeah, like I said, a case where this would be useful, like trying to determine if an image is dark, is say you had a watermark, then this perceptron would be trained to ignore the watermark based on those weights. So yeah, just a simple real world application. But that's not all I have. So up next is this. This is my actual real world application. So this is trying to determine whether or not a person is eligible or qualifies for a mortgage. So action taken is whether or not they qualify, and then you have loan amount. These two are IDs, so they are ignored. It's just for trying to find the reference to a person because there's no names or addresses that we're using to uniquely identify each record. So I'm going to be using a combination of those two, race and all these other things that count. This, what we're looking at here, is a modified version of the dataset, meaning it's just for me to track whether my output is right or wrong. But I do have this CSV file, and this CSV file has like all the data. So I modified this one just slightly. I moved the most important neurons that I thought were important and moved them over to the left just to see whether or not they lined up. Just making my life a little bit easier, but yeah, so if we run this, let me clear this out. It's going to be starting with random weights, none of that hard coding stuff like last time. And the axon would be 0 because axon to soma just doesn't have any weight. That's our output and our processing neuron. These are our variables. And then this is where I collect the values, or I set the values that we get. It's a very complex structure, and I could go over it in a lot of detail, but I don't think this is necessary for the demo. So let me just go ahead and run that. So first things first is it collects all the data from the CSV file. Then it sets it to a 2D array using pandas. And then from the 2D array, that's when I start processing stuff. And I also ignore the string, because sequence number comes back as a string. So I ignore that, set it to the 2D array. And from the 2D array, I basically treated it like the light perceptron, except with more neurons. And I collect the number of neurons dynamically. I don't hard code them at all. I just collect those input neurons from the sample, meaning only the variables that I select up here, only those variables are being considered. And then from then I collect them. And then these I have to hard set because there's a difference between a name and the value of it. So if you see here, like, for example, Hispanic or not Hispanic, Hispanic would be like a value of 1, and then not Hispanic would be a value of 2, right? Same with male. So because the data set, that's how it came in. So it's really no big deal. But let's go ahead and run it. So first things first is the income is 97 and the loan amount is 187. White female with a home purchase that is conventional. So if you look at this, like, this woman would qualify for a loan because she makes roughly almost 100,000 a year and her loan amount is only 200,000. She is getting a conventional loan, but the initial weights are random and the computer doesn't know yet that that should be correct, so it's wrong, and then it learns from that epoch, okay, let's update the weight by a learning rate of, like, I believe it's 0.1 that I set it to. I set it somewhere here. It's not important. But yeah, basically it does that for, there's about 3,000 records in here. There's probably more, like 46,000, but I removed any records that I pruned the records of records that were missing some information, or at least I tried to. So up next we have an income of 200,000 and the loan amount is 700,000. I don't know, but I'm gonna guess that it should reject it. Let's see what happens, and then it'll decide whether being a white male has more weight than the amount of money that you make. So, or if it's the home purchase, we don't know yet, but yeah, it gets it wrong because it says that it shouldn't. Let me see. 200, yeah. It says that it shouldn't. I said it shouldn't either, but probably the output here is that the person should. So if we take their this ID and I look for it in here, it's gonna take a while because it's Excel and it's CSV, not JSON. All right, we find it, and the amount, let's see, 202. Right, the action should be 1, and the accompanying action of 1 is loan originated. So yeah, it's pretty cool and it works. Now, if I set the learning rate, let me see if I can set the learning rate to maybe 1, and I restart. Let's pay attention to the first two, right? Because we went, we got a couple wrong right off the bat, right? We got a couple wrong. Let's see if by the time we get to Mr. 200,000 looking for the 700,000 loan amount. Where is it? Should be somewhere here. Yeah, for this one, let's see if it'll get it right with a higher learning rate. So, what number is that? Begin epoch. So this is 1, 2. Let me just look this up. Epoch. Okay. Excuse me. So let's see. Mr. 200,000 with 700. Okay, right here. So all right. Gets it incorrect. So 1, 2, 3. So it's about like the third, right? So let's start that up again with a learning rate now of 1. Income 202, 77,000. Let's see what we get. And with a higher learning rate, it actually learns that this should be correct a lot faster. So that's a really good output. I was not expecting it to get it correct, but yeah, I got it. And yeah, I'm really, really proud of myself for the way I set this up. I know a lot of other people chose different ways of doing it, but I set it up basically using a DAG, directed acyclical graph, and then I took it from there. Just yeah, modified the live perceptron to handle this sort of data. Yeah, that's it. Thank you for watching.